these same 3 leadership principles: thinking big, diving deep, and staying forever curious. Many of you may know him from his role as a popular television host or from his work on Tested, a content platform and community for makers and builders. Please help me welcome to the stage Adam Savage.
Thank you. Hey, Tom.
Adam, so great. Adam, I want to share with the audience a moment that we had at a conference earlier this year where I kind of jumped into a conversation that you were having with Brent from Blue Origin about the upcoming Orion mission. And you were having this very detailed discussion about, like, where is the water, and should you land on this equator, and what are the material properties of certain volcanic things for habitats? And I'm like, wait, these people, they're turning this science fiction into reality.
I totally remember that morning, and my knowledge base is very wide but super shallow. And a conversation like that about space just draws me in, and I'm ready to geek out for hours.
Yes. Well, I am very excited. We're going back to space. The Orion mission is real, and this is another example. The village are coming together on the mission.
Yeah, we're going back to the moon and beyond. It has been 50 years since we've gone there. It's high time that we went back.
High time. Very excited by this mission. By the way, I am now done with my mission. I leave you all in the great hands of Adam Savage. So great to see you again.
Thank you very
All
much.
Right, bye.
Another round of applause. Oh, this week is going to be memorable. You know when you're doing a really deep research dive and you open up the spigot of information, and it's like a fire hose just going past your brain. You're taking it all in. You don't know how to quantize it at all. And then at a certain point in the deluge, some little mailbox flag goes off in your head, and you go, wait a minute. I might actually understand some portion of this. The endorphin rush that you get at that second, which I'm still chasing my whole life, that endorphin rush is what this week is entirely about. You're going to leave with more questions than you arrived with, but that's right and proper because questions are where the action is at. If there's one thing I've learned about institutional knowledge, it's not about knowledge of facts, it's about knowledge of exactly what the right question to ask is. And we have a crazy cool lineup of speakers for you this evening. Get ready to be floored by unique perspectives of the Mars domains, from exciting new developments happening today to unbelievable achievements happening in the surprisingly near future. First up, Brent Sherwood from Blue Origin is going to tell us about the new space stations that they're designing for commercial activities. I'm just wondering if they have a hotel up there. Can I get a late checkout time? Then Dr. Shahini Ghose will brave the inescapably weird quantum reality of atoms and photons and tell us how quantum physics can be harnessed to transform computation as we know it today. Dr. James Crawford of Orbital Insight will walk us through the ways AI, machine learning, and geospatial analytics are helping to streamline operations in areas like defense, intelligence, consumer goods, and supply chains. Jesse Levinson from Zoox will show us how their fully autonomous, impossibly cute all-electric vehicles, sorry for calling them cute, are providing safe mobility as a service, bringing an entirely new experience for riders. And last but not least, theoretical physicist, best-selling author, science correspondent, and radio host Michio Kaku is going to investigate some of the most pressing topics in science today and explore exciting theories that could help us unlock some of the deepest scientific mysteries. So, without further ado, let's get started. Please welcome with me to the stage Brent Sherwood, Senior Vice President of Advanced Development Programs for Blue Origin.
Hello, everybody. Welcome to remars. We're going to start with the S in Mars. And as Ray Bradbury taught us many years ago, S is for space. So we'll be thinking big. I'd like to talk with you about activities and products and services and systems in space that are coming this decade, within just a couple of years. This is not concept, this is real. It's also not about machines and data doing amazing things in remote places in space. This is about people in space, bringing people into space, and what that will mean for us. This is what the future of human spaceflight was supposed to be. When I was born, same year as NASA, this is essentially what we thought the future would look like. I grew up in the 60s with Apollo and Star Trek and 2001, A Space Odyssey, and we all knew that there would be moon bases, hotels in orbit, cities on Mars. Hasn't happened yet. Some of us have been working for decades to make it happen. Today we're going to talk a little bit about why it hasn't and the fact that now it's about to. It starts with Earth. I'm sure you all think space is cool. It's much more than just cool. I would argue it's existentially important for the future of civilization. We evolved on and live on a vast planet that's wrapped by an extremely thin and vulnerable biosphere. And that biosphere has a finite carrying capacity. We don't know what that carrying capacity is. Population, industrial utilization. Maybe it's 15 billion people, twice what we have today. Maybe it's 10 billion, much closer to what we have today. Maybe it's 5 billion. Maybe we've already exceeded the carrying capacity of the biosphere, as we see in increasing environmental devastation and the existence of the 6th major extinction event that this planet has seen in its history, which we have created and are perpetuating. There are two paths from our state into the future. One is what Jeff Bezos calls rationing, stasis and rationing. That means allocating and sub-allocating in a probably very controversial and conflict-ridden way, increasingly limited resources to an increasing population, which is increasingly hungry for technological advancement. The other route is to unlimited growth. And the only way to do that is to open the infinite resources and infinite volume of space. There are only those two choices. We at Blue Origin favor the second path, and so we're working hard to try to build a future in which millions of people can live and work in space to benefit Earth. To get there, we have to go through what we call two gates. This is the only way we can break out of the limitations, the physical limitations, the energetic limitations that we have in this thin biosphere on Earth. The first gate is significant, dramatic reduction in the cost of getting into space and moving around in space, where we want, when we want. And to do that, Blue Origin and others are developing fully reusable systems, so we don't throw away the rockets and the spacecraft after we use them. This is a hard problem, but it's solvable, it's operationalizable, and that's what's happening right now. The other gate comes later, and that is opening the resources of space. You have to do both. We have to be able to get there inexpensively, and we have to be able to use what's there. And then we can unlock the future of humanity throughout the solar system. So, if this is so important, why hasn't it happened yet? Why is it not happening more aggressively now? Well, the world we live in is extremely different from the world of Apollo when I was a kid. Back then, we had the high priests of technology, white lab coats, pocket protectors, horn-rimmed glasses, and they were treated with respect by newscasters and the public. Think of how different today's world is. A highly cynical population, very young population. People with billions of people with access to information and disinformation with just a tap or a click. We see the continued effects of environmental devastation, the impoverishment of the biosphere as our legacy to future generations. And we now also see the ability of individuals to commit what we could call antisocial decisions or actions because they have their hand on the levers of tremendous power. As expensive as we think gas may be today, we actually are spoiled by cheap petroleum. We don't pay the full cost of petroleum, digging up these ancient forests, burning them, putting it in the atmosphere, CO2 going into the ocean, warming the planet, and changing everything about our biosphere. But while we're still spoiled by cheap petroleum, we also have access to space. And while the spending power of NASA is only 1/5 what it was at the peak of Apollo, we also have access to immense amounts of private capital. So can we think differently and weave these threads together, the realities of today, into the prescription for a program that moves us forward into the future? I use this model to think about what humans are good for in space. And in 60 years of reading and studying ideas and working with ideas that people have had, I've yet to come across one potential use of human spaceflight that does not trace to one or more of these four futures. They're very different. They require different types of technologies, different investment focus, different systems. They're not all interchangeable. So it's important, if we're going to invest, that we know where we're aiming, what we're investing in, and why. The four futures can work together, but they're not interchangeable. If all we do is explore, we'll never occupy space. Exploring is looking over the next hill, seeing what's there, mapping it out, studying it, understanding how it works, reporting back, for example. That's exploring. To explore well or thoroughly or inspiringly, we need to reach out very far. We need to find things that are genuinely new. Expanding is different. That means putting down roots, learning how to live, raising families, which in turn means emplacing all of the aspects of civilization that characterize our world. Now on Earth, expansion can follow exploration directly because we can breathe the air and drink the water, and the climate is temperate. There is air, for example. We can till the soil, we can farm the oceans, we can mine for minerals. In space, just to be requires building. It's not developing land that we find, it's developing the land and then improving it for human use. So that's harder. This is a bridge too far. No amount of government-funded exploration is going to enable human expansion into the solar system. There's too much else to do. So what's the solution? I think it's the other two futures. I think they are the bridge. Exploit and experience are the bridge from exploring to expanding because they are not constrained by government budgets. They are ways to access sources of capital outside the top-line budget constraint of federal appropriations. And you see just conceptual examples here. When we experience, we go, we pay, right? That's our own resource that we're spending. When we exploit, as a company, we're investing expecting to make a return. We're investing our shareholders' money in order to get a return. These are economic engines, and they're the only way that we can bridge from exploring to expanding. The futures are connected. So I'll talk for a moment about exploring and what we're doing today. NASA has the Artemis program. We're getting back to the moon to stay, learn how to put down roots,